Welcome back, folks, and we are in our discussion of redox, and really we're getting to a concept called electrochem, which is all based on redox. And one of the key ideas of electrochem is this thing called a galvanic cell. So let's take a minute and do a little talk about a galvanic cell. First here, let me give us a definition of a galvanic cell. So we want to talk about galvanic cells, also known as voltaic, right? So galvanic cells. And so what are they? Let me give you a proper definition. This is a device in which a spontaneous a spontaneous redox reaction redox reaction occurs with the electrons flowing through an external circuit. Through an external circuit. Okay, so that is my technical definition of a voltaic cell. And usually what we have is we will have something that looks like this, right? And so here's some kind of large beaker. And maybe usually there are two large beakers, so you have two large beakers, okay? And we have an external, we'll have to have things, we have to have a couple electrodes in here. So here's an electrode, and here's an electrode. And those two electrodes are hooked up by a wire, right? And then I'm going to have some fluid in here. I'm going to have a solution in here. And we're going to call one of these electrodes an anion, and we want to call another electrode the cation. Okay, the cathode. So let's call this one the anode. Let's call this one the anode. Just I kind of like the anode here. So that's the anode, and this is the cathode. And what's going to happen at the anode? At the anode, oxidation is going to occur. So at the anode, oxidation occurs. So oxidation occurs at the anode, meaning this is what we would call our oxidation half reaction occurs in the beaker with the anode. So what's going to happen in my cathode? Well, the reduction half reaction is going to occur in the beaker with the cathode. And the cathode, what happens at the cathode? Reduction occurs. You know how some people remember this? They remember red cat. Reduction cathode. Oxidation anode, I remember oxidation anode because in the middle of the word anode is an O. And yeah, that doesn't help me a whole lot though because there's an O in cathode. But for some reason, I always remember the O for oxidation. Good. So that means oxidation happens in one of these cells and reduction happens in the other. Well, what happens during oxidation? I'm going to have X go to X plus, right? That's oxidizing. And what happens? It creates an electron, right? So that's what's happening, meaning my X is my solid electrode, my anode. It is going into solution. Boy, I should have probably put this somewhere else. I'll put it down here. Oxidation X goes to X plus plus 1 electron, right? So that means my X is a solid, and it goes into solution as X plus, and what happens? It creates an electron. And where does that electron go? It flows through my external circuit over to where? Over to my cathode. So this thing starts building up with electrons, and what are those electrons going to do? Well, they're going to go in here, and what's going to happen over here? I'm going to have Y minus plus I'm going to have Y plus, excuse me, I don't like any of those things, do I? I'm going to have Y plus 1 electron going to form Y. So here I have a bunch of Y pluses in solution. They are going to hook up with an electron, and when they do, they're going to coat on this cathode as Y. So my Y starts going on to this cathode, and my anode starts diminishing. So my mass of my cathode increases, and the mass of my anode decreases, because what's happening to that X? That X keeps going into solution. So then, what happens to the concentration of my X plus here? My X plus concentration is going to increase. What happens to the concentration of my Y plus? Well, my Y plus is doing what? My Y plus keeps forming solid Y onto my cathode. So my Y plus concentration over time will decrease. Now, also, you'll notice then what's happening. I'm starting to get an imbalance in charge between my reduction half reaction, or within my reduction half reaction. I keep adding pluses here, right? Or excuse me, I keep losing pluses here. So that means my negatives, my other anion builds up in concentration here, and my X pluses build up here. So I'm building up a positive charge in my oxidation half cell. And to keep those things balanced, we add something called a salt bridge. Salt bridge. And it is something like you might have potassium nitrates in here. It would be a molten or a paste of, I should say molten, a paste of potassium nitrate. And so what will happen as these positives in my oxidation half cell increase, my nitrates start flowing over here to counter the buildup of the positive charge. Over here, I have my negatives for my anions that were in solution, and they are becoming more prevalent than the Y pluses, because my Y pluses are coating onto my cathode, right? So what's going to happen to even out that electrical charge? My potassiums start flowing this way, and I start getting potassiums in here, which will keep my charge balanced. And so essentially, that is a galvanic cell. Just remember a couple things, right? Oxidation occurs at the anode. Electrons flow from where? They flow from the anode to the cathode. Cathode red cat reduction occurs at the cathode. And that would be about it. All right, so I think we can answer our question. Let's go back and take a look at this. I have a galvanic cell composed of iron 2, nickel, iron 2, nickel, and nickel 2. All right, so here we go. So I'm going to have 2 beakers. And let's take a look up here. I have nickel, solid nickel, right? Yeah, I have solid nickel. And I have nickel 2 nitrate. Well, that's going to make up one of my cells, right? I don't know which one yet. I'm going to put nickel here. And that means my nickel 2 is going to be floating around in here. Okay, so here's my nickel 2. And then in my other, I have a solid iron, I believe. Right, I have iron, and I have iron 2, and my nitrates are going to just be spectators. So I have iron 2s floating in here, and I have iron, and these are going to be connected by a charge. And now we have to figure out which of these things is going to oxidize and reduce. And there's something called an a standard reduction potential table, and we'll get to that soon enough. But I'll tell you which of these is going to oxidize and which of these is going to reduce. Okay, let me see. What do we have? We have iron 2. Iron 2 says it's a negative 0.44. And nickel, 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 nickel. Nickel 2 is a negative 2.8. That means my iron is going to no, that means my nickel is going to reduce. Okay, so nickel reduces, so that means I'm going to have nickel reducing. So I have Ni2 plus 2 electrons goes to nickel. And that means iron is going to have to oxidize. So Fe goes to Fe2 plus 2 electrons. And when we get into our next section, I'll tell you how you can figure this out. But just take my word for it right now that this is what's going to happen. So this is what? This is my redox half reaction. And this is my oxidation half reaction. Oops, half reaction. Good. What happens? What's going to happen at this electrode? Well, at this electrode, what's going to happen? This is what? Reduction. So that means this electrode has to be called the what? Red cat, right? It's the cathode. So that is my cathode, which means that this electrode must be my anode, and which means that my electrons must flow in this direction. Now, specifically, what reaction is occurring here? Well, it's this reaction. My iron metal is giving up 2 electrons, so 2 electrons go in this direction. The iron metal becomes Fe2 plus and goes into solution, right? What happens specifically at this electrode? Well, my nickel is oxidizing, meaning I have these 2 electrons coming down from iron, and they are attracted to a nickel 2 in solution, and that nickel 2 then plates on this electrode as nickel. Good. And then finally, we need to have some kind of a salt bridge. I usually like to use potassium nitrate, and that will allow my charges to stay relatively balanced in the solutions, and will allow the electrons to continue to flow. All right, let's see. Did I answer all the questions? We drew it. What is the anode? The anode is, what did I say, iron. What is the cathode? I said it's nickel. In which directions the electrons flow? From the anode to the cathode. What do you recommend for a salt bridge? Potassium nitrate. All right, let's see if you guys can do the next one. And I might have to give you a hint, but let's see. Ooh, beautiful picture. Copper versus zinc. Okay, so I can give you the hint here is that zinc is going to oxidize and copper is going to reduce. All right. Give you a few minutes. Bring me back when you are ready. Okay, you should be ready. Let's see if you drew a beautiful picture like I did. Here we go. So I need more space. I have one of these guys, and I have one of these guys, right? And what did I said? I said my zinc is going to oxidize. So that means I have an oxidation half reaction. So this is my oxidation. We call this the oxidation half cell. Oxidation half cell. Good. And we call this the reduction half cell. Sorry about that. And so what's going to reduce my copper? What did I have? Copper 2 or copper 1? Copper 2. So my copper 2 is going to reduce to form copper. Good. I have an electrode in here. And what kind of electrode will that be? That will be a copper electrode. Over here, I'll have an electrode, and that will be a zinc electrode. They're going to be connected. Since this is my oxidation half cell, that means this is going to be my anode. Since this is my reduction half cell, this means this is going to be my cathode. My electrons are going to flow from my anode to the cathode. Good. What reaction is occurring here at my anode? This is the reaction that's occurring at the anode. This reaction is occurring at the cathode. So that means what? My zinc is going into solution, so my zinc, my concentration of Zn2 plus is going to do what? Increase. Good. Over here, what's happening? My Cu plus 2 pluses are picking up 2 electrons, and they are depositing on my copper electrode. So that means my concentration of copper 2 is decreasing. However, the mass of copper is doing what? Increasing. And the mass of zinc is doing what? It's decreasing, right? Because my zinc is going into solution. And the last thing I need to do, yoink, I need to add my salt bridge. And I'm going to go with potassium nitrate. And that's so I do not build up a positive charge over here, and I do not build up a negative charge over here. So my potassiums will float over here to keep my charge balanced in my reduction half cell, and my nitrates will flow over here and keep my charge balanced in my oxidation half cell. I think that will do it, and we will probably call it a day on galvanic cells. It's a quick one. All right, see you next time.